Hello, okay, Mrs. Todd here. We have 2 more lessons in the chemical reactions unit, the unit we were working on before we left for this extended break. So this is the first of 2 video lessons to get us through that. After this lesson, I'll be posting a worksheet with solutions that's called Predicting Products. So it's got synthesis, decomposition, combustion, single and double displacement all separated, predicting those products, including states if you're asked to. And then it has a question that has all of them mixed together. So again, a little bit trickier. Then we have one more lesson called net and total ionic equations. So I'll be posting a video for that. And then there will be textbook homework for that. And then I will post the test review and a practice test. So the board hasn't given us much direction about how to do assessments moving forward, like tests and things like that. So for now, you're just doing enough practice to make sure that you've learned it in order to potentially write an exam, and then for sure for next year if you're taking grade 12 university chemistry. We haven't had any direction about what assessment or evaluation is going to look like, so we're just going to keep learning for the sake of learning so that you're prepared for next year. Okay, so when you are predicting double displacement reactions, then first, again, the unfortunate analogy of switching dancing partners. Instead of a single displacement reaction, which has only one substance that is single, so whether it's a halogen or a metal, and it's going to kick out or displace the other halogen or metal in the compound. Now we're looking at 2 compounds that are going to displace something with each other. So it says always involves ionic compounds. Really, we want a plus and we want a minus. So if you look at this general example down here, then A and C are cations. So we write the cation first, and then B and D are anions. So then again, when you get a new compound in the products, you want to make sure you have a cation and an anion going together, so opposites attract. This year, what we're going to focus on is whether you get a precipitate formed, and then there's a very special case where a gas is produced. So when you have the reactants, they are always going to be aqueous, so that's always going to say AQ, and then you will have to be able to predict whether a solid is going to form. So how do we do that? So when you're talking about ionic compounds, again, if you have a plus and a minus together, say sodium chloride, then that's very stable. The overall charge on the compound is 0, so there's not a lot of reactivity there. So again, you need it to dissolve in water, so it dissociates, and you can then have the plus and the minus separating in order for displacement to occur. So in order for something to dissolve in water, then, or the tendency to dissolve in water, then, is called solubility. So this unit, we're just going to look at whether you get a solid or not, or whether something is soluble or not. Next, not the next unit, the unit after, we'll look at the amount. So solubility as an amount, how much is dissolving in water, and then next year in grade 12, we'll look at in cases where can we force substances that we would have previously said can dissolve, can we force them to dissolve in a tiny amount? Okay, so this is not this is a topic that's not going to go away. So you really have to make sure that you're able to use the solubility rules in order to predict whether something is going to dissolve in water. So the symbol AQ represents whether something is soluble, and then if something is going to be a solid, then we're going to use the symbol S. So similar to single displacement, you can get no reaction if there is no precipitate formed. But again, please think about, if we do write an exam or a test, that there's not going to be a plethora of questions that have no reaction, because then you're not showing me if you know how to use the guidelines. Okay. So how can we tell if an ionic compound is dissolved in water? So you need the back of your periodic table. If you don't have your periodic table, then I have put this on D2L. So this is the back of the periodic table. And here you can see that there are words that say soluble and there are words that say insoluble. So there are some substances that are very, very soluble. So you can see here in row number 1, that anything plus the alkali ions, lithium, sodium, potassium, rubidium, and cesium, anything you put with any anion, any negative ion, anything you put with those is going to make a soluble substance because they are small. It's easy for them to fit between the particles and fit between the water molecules in a sample of water. So then you'll have solubility. Same thing with ammonium. Anything plus ammonium is soluble. So ammonium is the only polyatomic ion that is positive for now. And then anything with nitrate, so anything you have with nitrate is also going to be soluble. Acetate is a polyatomic ion that is on the back of your periodic table. It's not one that you've investigated before yet, that you don't have to do the ite or the per, any of those with it. And then there are other ions at the side here. So some of them are just the IDE form, okay? And then some of them are like the sulfate form or sulfite. Okay, so you do, have to include that as well. So we're going to use this. So again, if you did not bring home your periodic table, there are many forms of the periodic table. You can just Google it, use your textbook, whatever. But if you want to use the solubility rules as it looks on the reference sheet, whether you write an exam this year or next year, it doesn't matter. I'm going to give you the same one. So if you want to use the same version that I have, again, there are plenty of versions of this as well. But if you'd like to get used to this one, then go ahead. You do need to be careful. For example, like if you look here where it says chloride and copper, it says copper 1 and copper 2 is not listed there. So you do want to make sure that when you have certain transition metals, that you are careful with those as well. Okay. So back to our note.
Mommy, I'm ready to have my bath. Mommy, I'm ready to have my bath. No.
Okay. So sorry about that. That was my son. Let's test these. So you go to sulfate, and sulfate is on row number 9 on this table over here, and we're going to do lead 2 with it. So sulfate, there it is. Sulfate plus lead 2 is going to be insoluble. So on your note here, then you're going to write soluble. For number 2, you have 2 options, because when you you can look either at the ammonium ion. So again, I said that was always soluble, or you can go down to sulfide. So here it is in row 10, sulfide plus alkali ions, alkali earth ions, or NH4, there it is going to be soluble. So that's what this first section here gets you to do. So again, nitrate, nitrate is row number 3. Anything plus nitrate is soluble. Then for chloride has 2 rows. So you look for, it says silver chloride. Unfortunately, silver has a weird symbol. It's Ag. So that is the first one listed there in the insoluble row. Calcium carbonate. Carbonate is number 14, and it's got quite a list there. So carbonates in general are very insoluble, like chalk calcium carbonate, for example. But you can see there, if you go Mg and Ca, oh, there it is. Ca is calcium. It is insoluble. So again, we'll just go over that one more time. So then you can, for the next one, you could either look at ammonium's row, which is number 2 here, or you could go to hydroxide, which is number 11 here. So hydroxide plus ammonium, there it is soluble. Whereas hydroxide and barium is also soluble. Okay. So then what happens when you are writing a reaction? So you have 2 choices. So when you have the reactants, they are always going to be aqueous, and you're either going to get a solid or you're going to get 2 aqueous products, which makes no reaction. So you should not get 2 solids. That doesn't make any sense. On paper and pencil, could you do that? I suppose, but that's not a practical thing. You would not have a reaction. You would not get 2 precipitates. That you can't extract them or anything like that. So practically, we are not going to do those. So if you get 2 solids, then you can tell yourself, "Oops, I made a mistake." Okay. So when whatever substance is listed as insoluble, that is the one that is going to be labeled as S. S stands for solid in this case. Okay, so first you have to do maybe what you did in grade 10, or, pretend like it doesn't even matter yet, the solubility. You have to displace or switch the ions. Then you determine the solubility guidelines. So when you exchange the ions, then you would have to do the crisscross rule for the products, etc. So, follow the rules for compounds, and then you have 2 possibilities. You're either going to get 1 precipitate, or you're going to get two products that are soluble, which means no reaction. And then if the reaction occurs, of course, always make sure that you make sure it's balanced. Okay, so determine the products, if any, when a solution of sodium sulfate is mixed with a solution of lead 2 nitrate. So often, if you struggle with this, I encourage writing out the word equation. Okay, and then it doesn't matter which one you write first. So now you're going to do sodium with nitrate. And lead 2 with sulfate. So it's up to you if you choose to do it the word equation, or if you can see it in your head, if you want to go check which one's going to be the solid now or do it after, based on the formula, because the solubility chart sometimes has the symbol in it. It's really up to you. Okay, so now sodium and sulfate. So sodium is Na+, sulfate is SO4 2-, lead 2, and then nitrate is NO3-. So the sulfate and the nitrate, those are found as forms on the back of your periodic table. They are polyatomic ions. So sodium has a charge of 1, but sulfate is 2. So that little 2 gets crisscrossed, and Pb now has a 2, which gets crossed all the way across. Okay, so when you do the reactants, you can either trust me that I've given you 2 that are not going to be insoluble, because that's not possible, or you can check yourselves. So then let's just do that. So now we have sulfate. Oops. Sulfate and sodium. And if you look here, so the first column, calcium, strontium, barium, radium, silver, mercury, and lead are insoluble. So sodium is not found there. So then it's considered in this row here. Many of them have this row here where it's any other cation. So a cation means positive. So anything else that's positive, then it's going to be soluble. So again, our reactant has to be soluble. Now we've proved it. So then we go to nitrate. And anything is soluble. Okay. And again, some of these are very common, like including nitrate. So you might find that you've got it memorized. You're like, oh, I know that nitrate is going to always be soluble. It's really up to you. Okay. So then these are both aqueous. Now we're going to switch the partners. Since I've written sodium nitrate up in my word equation first, that's what I'm going to write first. But then now you're going to re-crisscross. So the sodium and the nitrate are now going to go together, and they are both ones. And again, we just looked up nitrate. What did it say? Anything with nitrate was soluble? Oh, there you go. Oops. And then lead is going to go with sulfate. So now lead has a charge of 2, and so does sulfate. So they would also cancel out. So let's go check out lead and sulfate. Okay, so there's sulfate. There's lead, insoluble. Okay, so there's our solid, which makes sense. We want to have one solid. Okay, and now you just have to always check for balancing. Double displacement, like I've said, when we talked about balancing, are usually the easiest to balance. How many nitrates do we have? We have 2. How many do we have here? Oh, we have 1. Let's put a 2. Oh, now we have 2 sodiums. Well, that works out. Sulfate 1, 1, lead 1, 1. Okay, and we're done. So not too bad. So really getting enough practice with the solubility chart is sort of important here, and making sure that you know how to use that, because you don't need to memorize that. You'll always get that. Okay, so things can get a little bit trickier when you have if you're predicting the formation of a gas. So what I've tried to do with these questions, because they can be tricky, the question will say, such and such reacts with a double displacement reaction, and a water and a gas are produced. So when you see that, then you know, okay, that means that I have something weird going on here. Okay, I can't move this up from the middle of the screen, so I'm just going to write the example at the top here, but you can put yours underneath. There should be space there. So we're going to do if sodium carbonate and hydrochloric acid react, water, gas, and another product are produced. Okay, so there it is. It's going to say water and a gas. All right, so what I recommend you do is do these questions as 2 steps. Okay, so we've got sodium carbonate, which is aqueous, and hydrochloric acid. Acids are tough because at first when you go to use the solubility guidelines, it almost looks like you can't. But remember, there is always that row that says any other cation. So technically, hydrogen is a cation. So then you can, that's where you can get that, okay? So now we're going to switch the partners. So now we're going to get sodium chloride, which is aqueous, and we're going to get hydrogen carbonate, which is aqueous. Now, so maybe you see this, and I just called it hydrogen carbonate, but maybe you say to yourself, Miss Todd, that is also carbonic acid, which it is. You would not be wrong. So what happens when you get an acid or a base produced, then this substance, this carbonic acid, is what's going to break down into water and a gas. Even if you didn't recognize that as water and a gas, or as an acid, sorry, you cannot make water from this. NaCl has no H, no O, so you're not going to get water from that. So when it talks about another product, that is going to usually be an ionic compound, like NaCl. So the NaCl is not going to change. Okay, then what we're going to do is we're going to break down this carbonic acid. So it says water. Okay, so water's formula is H2O. Whether you put aqueous or liquid, that really doesn't matter. And then when you're trying to figure out the gas, you're going to do atom math. Okay, so if we have carbonic acid or hydrogen carbonate, it actually really doesn't matter what you think of, and you subtract H2O, then you get rid of these two H's and you get rid of one of these O's. And what are you left with? Oh, CO2. Is that a gas we know? Yes, that is carbon dioxide. Okay, so when you do these questions, look for the water and the gas thing. And then I recommend, see, I've shown, I first switched the partners here in step number 1. And then I took this acid and split it apart into water. And then I figured out the gas. Okay. So those questions are the tough kind, but I really try to emphasize that you want water and a gas to try to get you there. Okay. The last kind is neutralization, which is really not too bad at all. So we'll do HCl and sodium hydroxide. And then again, you just switch, you get, most of you would think of salt and water. And then if you remember that H and OH make water, there it is. Or you can certainly write that as H2O. Okay, so that's it. I highly recommend that you do the homework. Now, these questions from the textbook will just be for double displacement and both predicting using the solubility rules and the gas and water and some neutralization. And then I will put the predicting products worksheet so that you can practice everything all mixed together. And then, like I said, there should be one more lesson for this unit that I will post when I get a chance. You can clearly hear that I've got little kids too, but we're doing our best. So I hope everything is going well and that you're staying safe and social distancing and washing your hands, and I will chat with you soon. If you have any questions, please email me. If you do have a phone, you can screenshot and then email. Sometimes that's even helpful so I can see what you did. Like I said, there will be solutions for the worksheet, so then maybe you can check and see where you went wrong. I'm not sure, but definitely email me and let me know how it's going.